Let's get started on Chapter 9, Creating and Configuring Virtual Networks. In this chapter, we will discuss virtual switches, creating virtual switches, and adding virtual switches to virtual machines. We will look at virtual network interface cards and synthetic network interface cards. We will look at hardware acceleration, advanced features, and creating an isolated network. Before we talk about virtual switches, let's talk about physical switches. And I think everybody here knows what a physical switch is. A physical switch is a box which has multiple ports in it. And the purpose of a physical switch is to connect servers to servers, to connect workstations to servers, and to connect everybody to the router, which is our internet connection, to the outside world. Well, we will see that a virtual switch is very similar. A virtual switch is used to connect virtual machines to virtual machines, and it's used to connect virtual machines to the physical network interface card, which is located in the Hyper-V host computer. A Hyper-V host is a big computer, and this box right here is supposed to be a diagram of a Hyper-V host. There are multiple virtual machines running in the Hyper-V host computer. And there is typically at least one network interface card which is located in the Hyper-V host computer. And that physical network interface card connects to a physical switch, which connects to users at their workstations, and it also connects to the router, which connects us to the outside world. A virtual switch is a piece of software that connects virtual machines to virtual machines, and which connects virtual machines to the physical network interface card, which connects to the physical switch. A virtual switch connects virtual machines to virtual machines, and it connects the virtual machines to the physical network interface card. Creating virtual switches. You can do it two ways. You can create a virtual switch during the installation of Hyper-V, which we did in Chapter 7, or you could create additional virtual switches. First, let's review the installation of the virtual switch, which we did when we installed Hyper-V. When we installed Hyper-V, we went into Server Manager under Add Roles and Features, and we selected the Hyper-V role. We selected the Hyper-V role, and then we were prompted to create the virtual switch. We can see that virtual switches, we can see that virtual machines require virtual switches to communicate with other computers. After you install this role, you can create virtual machines and attach them to a virtual switch. One virtual switch will be created for each network adapter which you select. So you can see we have two Ethernet network interface cards located in this Hyper-V host computer. So I will select the first Ethernet card, and that will be associated with our first virtual switch. Now let's examine the virtual switch, and let's verify that the virtual machines are connected to the virtual switch. If I go to Server Manager, and then I go to Tools, and I select Hyper-V Manager. Under Hyper-V Manager, if I go to the physical server, and I right-click and select Virtual Switch Manager, we can see here's the virtual switch which we already created. It's associated with this Intel Gigabit network interface card, and I named it Virtual Switch 1. Now let's verify that the virtual machine is connected to the virtual switch. I will right-click on the virtual machine, and under Settings, under Network Adapter, I can see that this is associated with the virtual switch that says Virtual Switch 1. So now we can see that this virtual machine is associated with this virtual switch. Well, for the moment, it's the only virtual switch that there is. Now, let's look at creating a new virtual switch. you might ask, if a new virtual switch was already created at installation, why would you want to create another virtual switch? Or just to put it another way, why would you want to have more than one virtual switch? And the answer is so we can connect to multiple physical networks. In this example right here, we can see that inside our Hyper-V host, there are multiple virtual machines, and they are connected to a single virtual switch, which is connected to a single network interface card, which is connected to a physical switch, which connects to the outside world. What we can do is, if we want to connect to another network, we add an additional physical network interface card in that Hyper-V host and connect that physical network interface card to the physical switch, which connects to the second physical network which we want to connect to. And then what we do is we create a second virtual switch, and that second virtual switch is now associated with the second physical network interface card. And then what we do is we make sure that some virtual machines are connected to one virtual switch, which connects them to one network, and that other virtual machines are connected to the other virtual switch, which is connected to the other network. To create a new virtual switch, we go into Hyper-V Manager, and under the Physical Server, we right-click and select Virtual Switch Manager. And we can see there is currently one virtual switch which has been created. To create a new virtual switch, I click on Create Virtual Switch. Under New Virtual Switch Properties, I will give this virtual switch a name. I will just call it Virtual Switch 2, followed by, then I have to select the network interface card that this virtual switch is going to be associated with. Virtual Switch 1 was associated with the first Ethernet adapter, so Virtual Switch 2 will be associated with the second Ethernet adapter, followed by OK. We then get a prompt that says, pending changes may disrupt network connectivity temporarily. Do you want to continue? We click on yes, and that creates our new virtual switch. Now what we can do is move some of the virtual machines from the old virtual switch to the new virtual switch. I will select one of my virtual machines, right-click, and select Settings. And under Network Adapter, we can see that it is currently associated with virtual switch number 1. To associate it with virtual switch number 2, I select the drop-down and I select virtual switch number 2. This effectively moves the virtual machine called File Server 3 from virtual switch number 1 to virtual switch number 2. Then I click on OK and OK. So what we can do is we can create a separate virtual switch and then associate that virtual switch with the second physical network interface card, which is connected to a separate physical switch. And then after we have created that second virtual switch, we can take some of the virtual machines which were connected to the first virtual switch and move them over and connect them to the second virtual switch. So what this does, it allows some of the virtual machines to be connected to one physical network and some of the other virtual machines to be connected to another physical network. Let's look at the different types of virtual machines: external, internal, and private. If I right-click on my physical computer and I select Virtual Switch Manager, you can see that there are 3 types of connection types associated with virtual switch properties: external, internal, and private. If we go to technet.microsoft.com under types of virtual networks, we can see we have external, internal, and private. If we configure this virtual switch to act as an external virtual network, then what that's going to do is it's going to connect the virtual machines, and allow them to communicate with externally located servers and clients. In other words, we will be connected to the physical network interface card, and the virtual machines will be connected to the outside world. Another way to go is to select internal virtual networks. If you select internal virtual network, then this allows communication between virtual machines on the same physical Hyper-V host computer, and it allows communication with the management operating system. Remember, the management operating system is also called the host operating system, and that's the operating system that runs the physical Hyper-V computer on which all these virtual machines run. And then the third way to go is a private virtual network, and if you select this configuration, then this just allows the virtual machines to communicate with each other. Typically, when you're first setting up a network infrastructure, you first set it up as a private virtual network which is not connected to the outside world. And then after you have tested it, then you select externally connected external virtual networks such that your virtual machines are connected to the outside world. 3 types: internal, external, and private. Let's now look at virtual switch options, such as allow host operating system to share the network interface card, and VLAN, virtual local area network, VLAN ID for the management operating system. If we right-click on our physical computer and select Virtual Switch Manager, we can see that our virtual switch is configured to allow the management operating system to share this network adapter. So what this means is that the virtual machines will use this network adapter to communicate with the outside world, and also the management operating system, the host computer operating system, will use this Ethernet card to connect with the outside world. If we have only one Ethernet card, then they would have to share the same Ethernet card to connect to the outside world. However, if we had 2 Ethernet cards, we could configure the virtual machines to use one Ethernet card, and we could use the management operating system to use the other Ethernet card. And the reason we would do that is to keep management traffic and production traffic running on separate networks. A second option which we can select is VLAN ID. VLAN stands for Virtual Local Area Network. As you know, a single virtual switch can be subdivided into virtual local area networks. If you have divided your virtual switch into multiple virtual local area networks, the question is then which one is the management operating system going to be associated with? And in this example, I am associating the management operating system with virtual LAN 2. So that is the virtual LAN that the management operating system will communicate with. If I only had, if I was not using virtual LANs, then this would make a difference. It wouldn't make a difference. It only makes a difference if you have multiple virtual local area networks on that virtual switch. Now let's discuss virtual network interface cards. You already know what a physical network interface card is. It's used to connect a computer to a switch. A virtual network interface card has the same function. If we look in this diagram here, we can see the Hyper-V host has multiple virtual machines running in it. We can see that it has a virtual switch, which is connected to a physical network interface card, which connects to a physical switch. If we want to connect these virtual machines to the virtual switch, then we would connect them using virtual network interface cards. A virtual network interface card is a piece of software that connects the virtual machine to the virtual switch. A virtual network interface card is a piece of software that connects the virtual machine to the virtual switch. Now let's look at creating a virtual network interface card on a virtual machine. And you might say, why would you add a second network interface card if there's already an existing virtual network interface card in the virtual machine? And the answer is because you want to implement NIC teaming. NIC teaming is where you have two or more network interface cards working in tandem to provide additional bandwidth or to provide fault tolerance. I will right-click on my virtual machine and click on Settings. Under Add Hardware, I select Network Adapter and I click on Add. And this shows that we have now added a second network adapter, so now there are two virtual network interface cards associated with this virtual machine. I then select the virtual switch that this virtual network interface card is associated with, and in this example I will select virtual switch 2. What's the difference between synthetic and emulated network interface cards? Well, you already know that a virtual network interface card is a piece of software that connects virtual machines to virtual switches. A virtual network interface card emulates the Intel Gigabit 85579LM network interface card. A synthetic network interface card does the same job. It's a piece of software that connects virtual machines to virtual switches. But the difference is, whereas the virtual network interface card emulates a particular type of network interface card, in this case the Gigabit 85579LM, a synthetic network interface card has no counterpart in the physical world. Configuring the MAC address. A MAC address is a number which is burned into the network interface card. When you create a new virtual machine, you create a new virtual network interface card. And the virtual network interface card is assigned a MAC address from a pool of MAC addresses in the Hyper-V host. If I right-click on my physical computer and select Virtual Switch Manager, and I select Global Network Settings, you can see the MAC address range goes from, if we look at the last number, 00 to FF. So what that means is that we have 256 MAC addresses which are assigned to virtual network interface cards as they are created. And usually 256 is sufficient. If, however, you need more than 256 MAC addresses, then what you can do is you can edit the fifth variable right here, and you can see it's D2. If I change that to D3, in other words, I've incremented this by 1, now you can see that this gives us an extra 256 MAC addresses, a total of 512 potential MAC addresses to be assigned to virtual network interface cards when we create them. Hardware acceleration. Hardware acceleration allows the Hyper-V host computer to run just a little bit faster. We can use Enable VMQ, IPsec, which is short for TCP/IP Secure Offload, and Single Root I/O virtualization. Let's look at those three. If I go to a virtual machine and I right-click and I select Settings, under my virtual network interface card, if I select Hardware Acceleration, we can see I have three options right here: Enable Virtual Machine Queue, Enable IPsec Task Offloading, and Enable SRIOV, Single Root I/O Virtualization. If I select Enable Virtual Machine Queue, what that does is it allows the network interface card to perform the queuing of data coming in and going out. And the reason we want to offload that job to the network interface card is to lighten the load on the CPU of the physical computer. Similarly, if we enable IPsec task offloading, then what that does is it takes the job of IPsec, which is securing, it's encrypting TCP/IP traffic. What it does is it has the network interface card do that job, and what that does is it lightens the load on the CPU on the physical Hyper-V host. And we typically select a value between 1 and 4096. In this example, I will select 512. And then we have another variable here. It's called single root I/O virtualization. And if we go to technet.microsoft.com, we can see that single root I/O virtualization provides remapping of interrupts and DMA, direct memory access, directly to the virtual machine, thus bypassing Hyper-V. And what that does is it increases network throughput and reduces the load on the CPU of the physical computer. So I will enable SRIOV, single root I/O virtualization, to lighten the load on the CPU of the physical computer. Hardware acceleration includes enabling VM-Q, and what that does is packets are queued on the network interface card instead of on the physical host computer. IPsec offload is where IPsec processing is performed by the network interface card, and single root I/O virtualization gives increased performance and it reduces the load on the CPU. That's what all three of these items do. Of course, that assumes that the network interface card is capable of performing these hardware acceleration features. Now, let's look at some advanced features such as static MAC addressing, MAC spoofing, DHCP guard, router guard, port mirroring, and network interface card teaming. If I edit a virtual machine and under hardware acceleration I select hardware features, under MAC addresses, typically MAC addresses are dynamically allocated. That's where the Hyper-V host issues MAC addresses to the virtual network interface cards from a pool of MAC addresses. We just looked at that a minute ago. If I want to configure a specific MAC address to this virtual network interface card, I select the radio button that says static, and then I can type in the exact MAC address that I would like to assign to this virtual machine. We typically do not do this. Now here's another operation. MAC address spoofing allows virtual machines to change the source MAC address in outgoing packets to one that is not assigned to them. Typically, you would not select this option. You would select this option in specific cases that requires that the virtual machine be able to change the MAC address, but that's the exception. You would typically only use it if you were going to use failover clustering. If we look at DHCP guard, we can see that DHCP guard drops DHCP server messages from unauthorized virtual machines which are pretending to be DHCP servers, and I will enable DHCP guard. Similarly, if I enable router advertisement, then what that does is router guard drops router advertisement and redirected messages from unauthorized virtual machines pretending to be routers. Another advanced option we can select is port mirroring, and port mirroring is where you want one virtual machine to see all of the traffic going in and out of other virtual machines, typically because you have a protocol analyzer and you want to measure all traffic on the network. Typically, you would not do this for the average user. You would just do this if you were using a protocol analyzer. And then network interface card teaming we've discussed before. Network interface card teaming is where we have two or more network interface cards that work together in tandem to provide increased throughput or fault tolerance. Advanced features include static MAC addressing, MAC spoofing, DHCP guard, router guard, port mirroring, and network interface card teaming. Creating an isolated network. When we first install and set up a new network, we install it and we test it in an isolated environment. And then once we know it works, then we extend the production network into virtual space, which is just another way of saying we connect it to the outside world. In this example right here, you can see that we have virtual machines which are connected to each other, but not to the outside world. So when we were first setting up our network, we'll make this one the DHCP server, and this one the DNS server, and this one the Active Directory server. And then once they're all set up right, and after we've tested them, then we extend the production network into virtual space, which simply means we connect the virtual switch to the physical network interface card, which is connected to the physical switch, which is connected to the outside world. Chapter 9, summary. In this chapter, we discussed virtual switches and creating virtual switches. We looked at adding virtual machines to virtual switches, virtual network interface cards, synthetic network interface cards, hardware acceleration, advanced features, and creating an isolated network. And this concludes Chapter 9. Thank you very much, and have a nice day.